Okay, so in the previous two problems that were on the notebook file, we found a specific value of delta for any given epsilon. So we weren't proving the existence of a limit, we were just saying if we were given some epsilon by Dr. Ron Larson, evil Dr. Ron Larson, then we could come up with a delta that would always get us into that interval that he had given us. But if we want to prove the existence of a limit, then we have to show that there's a delta for any given epsilon, not just this random one that was chosen for us by the book or by the book's author. So that's what we're going to be doing in these next two problems. I'm just going to walk you through one of them and then hope that it makes sense. And then the second one is over here, and I don't know, we'll see how it goes. So try to follow through these two, and then if it's a problem, then we'll talk about it in class on Wednesday. So again, what we're trying to do is we're trying to find a delta that will be in terms of epsilon. So if we're given any epsilon, we're saying our delta would be somehow related to that epsilon that we were given. So we're going to use the epsilon delta definition to prove, in this case, that the limit as x approaches 2 of 3x minus 2 is equal to 4. So the first step, I wrote my proof, the actual proof in blue. So the first step of the proof is just to state that we're going to let epsilon be greater than 0. And so then in the brackets right here is just kind of a reminder to me of what I'm doing. Okay, so the delta epsilon definition of a limit tells us then that we have to find a delta so that whenever x minus a is less than delta, and in this case x is approaching 2, so just below it I wrote x minus 2 is less than delta, then the absolute value of f of x minus L is less than epsilon. Or again, in this case, underneath it I wrote the absolute value of 3x minus 2 is minus 4 is less than epsilon. So now, before I go to this choose delta equals blah, 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 I need to figure out what delta equals. And to do that, I have a little scratch work, and my scratch work is over here in green. So even though my proof is kind of flowing like one complete thought, in order what to do next after my little brackets up there, I had to do a little scratch work to figure out what to choose for delta. So again, we want these two absolute values expression that we have up here at the top of the page, we want those two things to match. So if I simplify the 3x minus 2 minus 4, that simplifies to 3x minus 6. And if I pull a 3 out of that absolute value bars, it'd be 3 times absolute value x minus 2. And that would have to be then equal to 3 times delta, because up here we had the x minus 2 is less than delta. Okay, so if I've got 3 times x minus 2, then it needs to be 3 times delta. And so then in order to figure out what epsilon to pick, basically what you're doing, if you're taking, what you want to figure out is you want to figure out what value of delta could I plug in so I'm going to end up with epsilon at the end. Okay, so basically if I solve this delta, I would divide by 3. Okay, so let's see if that makes any sense at all when we go through the proof. So now I'm going back up to the proof where it says choose delta equals 3. So maybe I could like highlight that or something. So I did my scratch work, and so now I'm over here. My proof is continuing at choose delta equals epsilon over 3. So what that means then, and so what I'm basically going to do is I'm just going to write the scratch work that I had over here in green. Okay, but again, the important part of the green was I needed to do this green scratch to help me figure out what to pick for delta, to figure out what to write in this highlighted box. So this is going to seem very familiar. So if f of x minus L, that would equal, when I plug everything in, absolute value of 3x minus 2 minus 4. And then again, when we simplify that, we get 3x minus 6. And then we simplify it to this next line here, and I've got 3 times the quantity x minus 2. I could take this 3 and put it out there, but I just did not write that, and now I can't really fix it. So in your notes, you could write it outside the absolute value bars. And so this has to be less than 3 times delta. But remember, for delta, I chose epsilon over 3, okay? So it'd be 3 times epsilon over 3, which simplifies to epsilon. So again, what we showed is that no matter what epsilon we were provided by the book or by some villain who's trying to trick you, okay, all we have to do is pick a delta that would be 1/3 of that epsilon, okay? And then that means we would always land in that range that we were trying to get into. So hopefully that makes sense. Again, in the next example, it's the same kind of idea. The steps are all written out. In this case, my scratch work got kind of big, so I still wrote my scratch work in green here. And so this helped me figure out like what to pick for delta. And then I went back, I chose delta, I plugged everything in, and again, the whole point is when you plug in that delta that you picked in terms of epsilon, when it simplifies, you get epsilon. So I'll put a couple of these online to do. Try them. I'll also have you do a couple of ones where I'll give you a specific epsilon, and then hopefully we'll kind of sort of quickly finish up 1.2 on Wednesday, and then we'll move on to 1.3. Thanks, ladies.